right, we're nearly there, almost there. So this is joint work with my PhD, former PhD student. She's now graduated. She graduated before Christmas, so she's now Dr. Claire Mullen.
Lovely.
And I said joint, she did 99% of the work. I get to fly to Cape Town to present it, so that's the nature of the relationship between supervisors and. So she did a lot of work on Maths Fit, which I spoke about earlier, and also Anthony Brown spoke a bit about it, so I won't rehash a lot of it. Now, how do I move on? It's not moving on for me.
Probably need to get your mouse over the
Oh.
screen again.
You're looking for it. Either one side or the other. There, that's all flash.
There
There.
we go.
Am I there?
Move it
Yeah.
up a bit,
Yeah,
otherwise
move
you're
it
gonna change. There we go.
And click.
And use your over arrow.
No.
Okay, so otherwise,
Can I
if you
do
just
it?
Go down a bit, there was a, there.
Yes, okay,
There we go.
good, okay, so I'm going to fly through this. We know about this transitions from school to university. So in Ireland, you can go straight from your leaving certificate. That's the typical traditional student, age 17, 18, goes from their leaving certificate into university. Then we have alternative routes. So there's many of them. We have students who have maybe a disability who have come in on lower points. So matriculation points, they're allowed to come in on lower points. You have students, mature students, you've got international students who all come in via various routes. So we were just concerned about all these students coming through in the COVID era, since when we started in 2020. And the school closures, and I think I've spoken about that, what gaps were they going to have. So just, this is more of like a literature review of diagnostic testing. And I've taken, or Claire has taken these papers. We could have taken a selection of them, but they're mostly from journals that John and Alison and I publish in. So I'm going to call them just IJMS, International Journal for Mathematical Education in Science and Technology, Teaching Mathematics and its Applications, TMA, and in the US, then you see things published in Primus. So I think there's three good journals for practitioners, so lecturers. You don't need to know a whole lot of highbrow mathematical educational theory to get published in these things. So all these papers are literally about diagnostic testing. You can read them, talks about the methodology, the results, the implications for students. There's no theories that we have to learn a philosophy degree to understand. So that's why I like them, and I think they have more impact in terms of trying to help students worldwide. So first thing I'm going to talk about is just current practices. So that's an overview. So you can see that's already 15 years old. That's from the UK. And then Claire just took three decent papers about diagnostic testing. She was trying to go for geographical spread and time spread. So I think one is from Pacific Ocean. Lots of countries joined together to do an online diagnostic testing, and I think the other two are actually UK. And then earlier I mentioned what was the student perspective. So the decent paper there that actually comes from my colleagues in Ireland about how do students feel about diagnostic testing. Now I have to get that thing back. And I'll finish with Maths Fit. So this was a paper of Gillard, Levi, and Wilson from 2010. So they emailed 38 UK universities. They got 20 responses, and 12 of those universities used diagnostic testing. So I can imagine that's almost doubled now if that survey was retaken today. So why use diagnostic testing? So stuff we've already said many times today: identify knowledge gaps, make comparisons, what are the math support needs, resource creation, and so on. A big thing in diagnostic testing literature was paper-based versus computer-based. So with paper-based, we have the advantage of seeing the students' workings. So they might have got the answer wrong if it was multiple choice, but their workings could be correct, and that's not going to be shown up in a computer-based system. But I think with your grade scope, I think that really changes the picture there, because we can see grouped together students' handwritten. So that's a huge game changer that's helped diagnostic testing. How are they used? Usual stuff: tutor student discussions, research student profiles, revision areas, advise math support, track at-risk students. Is it effective, necessary to identify student strengths? Evidence or opinions about the value of diagnostic testing and difference in expected versus actual results. So that's a decent paper to just get an overview of how 12 UK universities were using diagnostic testing up to 2010. And again, like Alison said earlier on, it's good research practice to use the same diagnostic test if you want to do a longitudinal analysis, compare 1980 students with the 2000 year students. So, okay, so students prefer online. That came out of a Sharma now and Bali, and you can see that. Don't know that name. So students tend, this is the convenience of online. And one interesting finding we got from Claire's PhD was in the COVID year, students had to be at home, so they had to take their diagnostic test. And we asked them not to use calculators or not to use Wolfram Alpha or not to use online computers and all that. Of course, we had no way of policing that. And then the following 2 years, they were back on campus. So we actually had proctored diagnostic testing. So we had tutors in the room and there was no statistical difference between the results. So either students weren't cheating at home or they were cheating badly at home. So there was no difference. So specific examples. So this is another paper, 20 years old now, Lee and Robinson. So these are UK researchers and maths lecturers. So they were looking at kind of a novel way to look at diagnostic testing. It goes back to, again, Alison's point of experimental design. You really want to think about what you want to get from a diagnostic test. You just want a snapshot of time? Is it you just want binary, yes, no? We actually put a lot of time and effort into actually getting the students' confidence in their answer. So there was 4 options, say A, B, C, or D, and then E is, I'm very confident with my answer. F might be, I'm not at all confident in my answer. So you want to find out students' confidence. That's a way of finding out where they're at in terms of their confidence when you don't have access to their handwriting or their rough work or their sketches. So these guys came up with a paired question diagnostic test. So they had 20 questions and each question had 2 pieces to it. So the first piece and the second piece were actually examining what they thought was the same skill. So we'll talk about validation and reliability in a second. So they were trying to see, like, if they got question 1 correct, was question, like we'll call it 1A and question 1B, they're assessing the same scale. Got question 1A correct, they should in theory be getting question 1B correct. But they found it was enough of getting 1A right, 1B wrong, and vice versa. So that was a nice, just going to bring on a lot of these. So odd and even here just means odd are the one first part and the second part. So that we're getting the first part correct more often than the second part. And this is what you want to see. You want to see them getting both parts correct, but only half of the questions were answered correctly in 2 pieces. This is good in terms of identifier for what Alison would call them. They were getting them wrong in both pieces. But this is not so good. Getting the first one right, the second one wrong, or the first one wrong, the second one right, even though they're assessing the same scale. So they're the ones that, what would you call that? Indicative, or the different word you had?
Non-informative.
Non-informative. So again, a critique then of this kind of paper was good. Even though they thought they were assessing 20 different scales, 5 of the questions were actually testing the same scale. And we don't want that. Why waste the students' time? This is where Don's idea of adaptive stuff. Ask them somewhere in the middle. If they get that wrong, everything that depends on what wrong. So 15 did not. So again, lots of time should go into the thinking and testing of the diagnostic test. Amount of steps, different. Okay, yeah, so even though 1A and 1B should be assessing the same thing, they found that in 14 of the 15 questions, the number of steps the student had to take in 1A was different to 1B. So that's not really assessing the same thing. Then if I need to differentiate a function that has a chain rule in it versus a product rule in it, they're not really assessing the same thing. So yeah, so difficult to categorize and difficult to make any research implications based on stuff like that. So it's just have a good think about what you're using the diagnostic tool for, and really super testing your questions with colleagues or with other universities. Otherwise, you'll get someone like me coming to South Africa to critique these papers, and that's not what we're at. No. Then this was from the online stuff. This is Sharma and those people's names. These are the Pacific Ocean. So there was lots of countries involved in this. I can't remember the number of countries, but there was hundreds of thousands of students involved. So this is a much bigger sample size, and it was online. And what did they find? We'll just rush through this. 12 countries, 14 campuses, covering an area of 30 million square kilometers. And most of the students did not have English as their first language, so the test was conducted in English. It had instant feedback.
So again, it was an online thing. It wasn't as sophisticated as numbers, but it did have feedback for the students once they answered a question incorrectly. And they actually give their degrees based on a lot of these multiple choice tests. But again, they did a questionnaire. There wasn't not a very big response rate compared to the amount of students involved, but again, the majority for online tests, that the instructions or theories and follow, and they found that remedial activities were useful. So they must have been giving feedback on what to do next if you did poorly in such a certain section. And then I give a shout out to another Irish couple, Anne O'Shea and Dermot Hyland in Maynooth University. They've done a similar thing where they looked at Irish universities, how many were using diagnostic testing. I think there was 12 universities. Ireland is small. We only have about 12 universities. I think all 12 were using diagnostic testing, and they looked at what questions were being used and what questions were being answered well and not so well. And again, I think it's worldwide. Students tend to struggle with algebra functions, and therefore they can't do this stuff, even though they'll say organization. When you drill down, you can't do manipulation of algebraic symbols or whatever it is. Again, the timing is important. I think, Alison, did you say 90 minutes for the Alex thing?
Yeah, it's 7:59.
Yeah. So we, again, with Claire's help, we kind of evolved tests to come shorter and shorter each year. We just found having it for an hour, we just lost students that weren't able to keep their attention going. So we actually got it down to 40 minutes. We kind of found that was prime in terms of timing. Again, you have to make decisions then of what you're going to cut out. But I think a well-designed test, and we also moved from questions. I think we had 30 the first year, and we've gotten down to 24 questions now, 8 in each section, about 40 minutes. And then this is related to the South Pacific University. They had a mixture of easy, intermediate, and hard. Whereas in Maths Fit, we were just looking at what we would call the basics. So what students should know about the age of 15. So what we call the junior certificate. So to take that examination around age 15, by the university at age 18, they'll have done a leaving certificate, but we wanted to see, do they still know the basics from junior certificate? And you can imagine the results. And so that's 2 quick examples. I think I have another one. Oh yeah, what was interesting about this one was that they actually looked at Bloom's taxonomy. So, you know, the kind of recall is the lowest level of cognition, and then the high stuff. So they Claire did a little bit of work on that, but it was hard to do that when really we just want to check their basic numeracy and stuff like that. So you weren't going to put in long wordy questions or ask them to synthesize or stuff like that. But that was an interesting take those guys did. This was from the UK, Gallimore and Stewart. And let me see, what am I getting at here? Okay, yeah, so that's just a particular example, a bit like Alison. They tried to do an analysis of all the students. They had a very small sample size. I think they had 40 students like that, but it was the first time we saw something. I don't think I was aware of Alison's work at this stage. First time we kind of saw an analysis of the subparts of questions for each student. Now, again, it was tiny, 40 students. You have, was it 180,000 students or something? So again, just the first kind of published work on that kind of idea. What is fundamental and what can be used in terms of math support. Yeah, so it was 2008. Correlation between the diagnostic test and the final exam was high, support needed. Okay, so they ran some linear regression, which you might think is pointless with n equal to 40, but the students were happy. Again, just coming back to that kind of common theme, students do like to be tested, they do like to know where they are in terms of beginning their university careers in mathematics. So this was an Irish one then, conducted basically by the same person, Evelyn Lynch. So she used to work for DIT, Dublin Institute of Technology, is now at DCU. She's kept the kind of same diagnostic test running for 20 years now, I think. So it's 15 MCQs, and she gets them to do it in their orientation lecture, which is clever because everyone turns up to orientation because they get the freebies and whatever they get. And here's a maths test. So again, quite cleverly thought out questions. And if they do badly, I don't know what fail is here, but if they fail, they are enrolled into a 2-week refresher course, which will go coincidentally with the first maths course. So that it's a little bit of an extra workload for them, but if they're interested in passing,
they should go to the professional course and or attend math support, MS's math support. NUIM is the National University of Ireland Youth, so not too far away from DCU, and these people would kind of work together. They would share diagnostic testing ideas and actual tests themselves. So again, if you failed here, you were asked to subscribe to an online maths proficiency course, and that's kind of what gave us the idea for our refresher course, with the video, the PDF, and the numbers interactive question. And follow or math support if they wanted. Okay, it wasn't mandatory, but they could attend, and there's lots of nicer numbers there, any from 660. The paper-based thing which might have had to be corrected by hand. I don't think we do that anymore. The Renews one was online, it's smaller number of students taking in 5 key open questions, and they did a thematic analysis of the students' opinion of the diagnostic testing, the timing of it, how clear was it in terms of what it meant for their university mathematics courses. So students generally more suitable time to sit the test. This was week 0 again in DCU. Anyway, did the students feel they'd achieved its aim? Most students thought so. Was it a good or a bad idea? 9 out of 10 students thought it was a good idea. Sufficient feedback, maybe that could be better. So students felt that they didn't get, well, I don't know what does 60.6 mean, but I guess you'd like that to be higher. You'd like students to feel that they got more feedback. And final comments, overall positive, good that it's seen as a spur for math support, surprising lack of anxiety, surprising want for more feedback. So students want more feedback on their mathematical errors. It's a good way of advertising the math support centre, and the weren't as anxious as we expected them to be. You have a quick question there?
I think it's just,
Yeah.
I think this is excellent to take it during orientation. In UCT, we have like 2 weeks of orientation, which is a long time.
Okay.
During the parent orientation, it's like 3 weeks.
Yeah.
So we could also include some form of diagnostic testing
Yeah.
during that period, so that we use that to also complement the national benchmark,
Yeah.
the MBT results, you know. So yeah, I was just thinking about,
Yeah,
I think
no, it's a good
orientation
point.
time is
Yeah.
the best time to do it.
Probably the biggest crowd you'll have in your lectures is orientation week, or the last week when you say, here's the hints for the exam, and everyone turns up, and that's when you get them to do the feedback on your teaching. You know, it's a little tricks you adopt. But yeah, thanks for that comment. Okay, so Maths Fit, I'm not going to run through this horrible slide because we've kind of talked about it. We put a video up online. Welcome to UCD. Here's Maths Fit. We're worried about your math support. We put it in student-friendly language. We never use the word diagnostic test, by the way. It's a proficiency quiz. So we've done a little bit of work on that, and through colleagues in psychology, they said no one likes a diagnosis. No one likes to feel like they're being tested. So proficiency quiz, much nicer than diagnostic.
We use skill check.
Skill check, yeah. Yeah, and maths, even Maths Fit is kind of the
Maths
analogy of keeping
Yes.
fit. If you're keeping your maths brain fit. It's like swimming analogy. So lots of pre-survey questions I mentioned earlier. Bad idea if you're really not going to analyze them. So unless you have a team of PhD students or a team of very eager colleagues to analyze it, keep it short and simple. 3 sections, post-survey. I spoke about the gold, silver, and bronze, the categorization. These correspond to the automated emails. So this Brightspace has this thing called intelligent agents, and it just automatically sends out the email, I think within 12 hours of you taking the test. Depending on how they did these 5 categories, they will say, you should watch this video and take these numbers questions, or you should attend the Math Support Centre. If they did really, really well, they were asked to join a group where they would be the kind of tutor. So they would be tutoring their peers. If they did really poorly, they were asked to look at the Moodle videos, attend the Math Support Centre, and join a study group of similar people who did bronze. So there were, Alison?
Takes the state, right? I mean, the math side of questions that you asked, you just haven't used them, but you haven't used them yet. I
Yeah.
mean, there's lots of things you could do
Yeah.
down the road.
Yeah.
Looking at information in terms of retention at university, progression post degree, graduation, did those feelings affect
Yeah.
things? Right?
Yeah, no, there's lots. I think the only issue is the ethical application. You kind of have a time limit on how long you can use the data. You can apply for, I think, 5 amendments. I think we probably used 3 or 4 because I think we added researchers. We might have added Don at one stage for Claire's work. So you can add a researcher. You can ask for an extension of the time. But I think if you keep doing it, they'll say, oh, you've gotten a lot out of this data. It's time to destroy it or archive it or whatever. But yeah, it's a good point.
So what is this? So this is just gives you an idea of the engagement. So this was the first year we ran it, and we only used 2 modules that year. So that was mathematics for agriculture and health sciences, which has about 400 students, and mathematics for business and commerce, which has about 550 students. That's our biggest module at the university. So as I said earlier, the agriculture lecturer didn't want any continuous assessment marks going for the diagnostic test. So he was happy for them to take it, engage with it, but he wasn't giving any of his marks to it. Whereas the commerce lecturer was very happy. He said, yeah, take 3.3% because all my web work quizzes are worth 3.3%. I think he was only taking the best 6 of 9. So it was no skin off his nose to include the diagnostic test. So that had a huge impact on engagement. I think it was 90-something% of the commerce engaged with both attempts, and 50% maybe of the ags on the first time, and then almost 0 on the second time. But weren't interested once term started. So you see quiz attempt 1 and 2, refresher course use. So Claire has dug deeper into the refresher course, looking at the analytics on Brightspace. We can see what topics they refreshed on. Like if they got this question wrong, were they actually looking at that topic, or were they just using the refresher course? Because it would take you probably 2.5 hours to get through the entire refresher course if you were to watch every video from beginning to end. But as I said earlier, we found that they were looking at the numbers questions more than anything else. Because they were well written, there was good feedback in them, and to my surprise, they were more likely to do that than watch videos. Because the videos were well designed, they were short. Some of them were created by ourselves, some of them were taken from Khan Academy or whatever, but they were short, snappy, and somewhat interactive. So there was nothing longer than 4 minutes or something like that. But not students went for the numbers. Okay, so this is just.
Why did you? Did you maybe look into?
We didn't really. I think that kind of finding came after we'd done all the post-survey stuff. But most of the post-survey stuff was like, how do you think maths fit could be improved? How do you think the refresher must be improved? So it's only been clear maybe in year 3. So she had 2 years of data to work on in year 3. That was the problem because it was evolving all the time. She was analysing year 3 stuff in year 4, and PhD is only a 4-year thing. So time kind of caught up with her. But I think that finding came after that we found that they looked at more numbers questions than videos. So we didn't really get to ask why. So we have to kind of surmise that they're better than videos, or I don't know. This is just a screenshot of the last page of Claire's thesis. So she has 4 findings. These might sound very obvious, but in the context of first year non-specialist mathematics, so non-specialist, that's service, we've been using the word service, that these students will not go on to get a mathematics degree. They want a commerce degree, an engineering degree, an agricultural degree, or a science degree. So student engagement with a mathematics diagnostic and support program, MathsFit, was high, particularly when students were rewarded with module assessment marks for participation, 3.3% being the highest. We offered 3 in another one, I think 2 in another one. Engagement with an online refresher course increased when the course was hosted within the university VLE and when students were given in-class time to explore it. Finding 2 was students struggled with functions and calculus across all modules, even the engineers. Students from modules with higher entry requirements were more proficient at algebra than those in modules with lower entry requirements, and students were generally proficient at arithmetic and trigonometry. Okay. Apart from the business students, which is not that surprising, business students don't need trigonometry. A virtual learning environment. So our Brightspace or our Moodle or our Blackboard virtual learning environment. There's another word on that. Is it LMS? LMS, Learning Management System. And I think that is my second last slide, and the time is up. Finding 3 was students spent significantly more time attempting interactive practice questions, i.e. numbers, than watching videos to refresh their mathematical skills. Student engagement in each section of the refresher course was not reflective of the advice given in feedback emails. So even though we might have said, you really need to concentrate on functions and calculus, that didn't necessarily mean that they took numbers questions on functions and calculus. There wasn't any statistical association. And finding 4, finding last, was diagnostic test results, previous mathematical attainment, previous examination system, and international status were predictive of students passing their mathematics module. Gender, engagement with the refresher course, and attending the MSc were not predictive. Attending the maths course didn't make a difference, sadly for us. We're not predictive based on a well-fitting logistic regression model. So there's lots of data. I'm very happy to share Claire's PhD, which some of the papers are published, but this kind of quantitative stuff is not published yet. So I'm happy to share the relevant chapters with people. You can really go in, that nice charts, a bit like Alison's nice color charts earlier on. You can really go in and see Did one visit to the math support center make a difference? Did 2 visits make a difference? Did 3 visits make a difference? Did greater than 5 visits? Did a visit in November have a difference than a visit in December? Stuff like that.
It's interesting, we did the paper, Marilyn and I, on retention associated with math support. And the odds ratio for a student not being retained if they didn't attend math support was like 1.6 overall. I think for Indigenous students, it was like 2.75. So there's a huge effect on retention, maybe not on whether they passed the course or not. In
Yeah.
fact, the only grade which had a significant effect was failing students, where we retained a lot of failing students who failed the subject,
Okay,
who came to maths support was significantly
that's
higher.
interesting. Yeah,
So that paper's published, that's in
IGMS. Yeah, yeah,
last November, I think.
yeah.
Right. Well, I think that moves us into our last big thing for